Okay, students. So in Vigenère cipher, we have a plain text give money and key is equal to lock. And in Vigenère cipher, we use 26 by 26 of matrix, 26 by 26 matrix, in which rows represents a key, rows represents key, and columns represents plain text. For this purpose, we have a table that is called Vigenère table. Okay, so let's say we have a table that is called Vigenère table. This is our Vigenère table. So how to convert this plain text into cipher text? We have a procedure for it. Okay, so let's start converting the plain text into the cipher text by using Vigenère cipher. Okay, let's suppose we have plain text give what. Okay, we write plain text in this way like this, and we have a key, k key, we have a key is equal to lock, and plain text we have give money, and we have to convert this give money into cipher text. Okay, so we write here key lock, L-O-C-K, L-O-C-K. So no, here we have only 4 letters of key, 1, 2, 3, and 4. But in plain text we have more letters than a key. So we have to repeat these. We have to repeat this lock until both are equal. Okay, so we will repeat the key L-O-C-K-L, L-O-C-K lock, L-O-C-K lock, and L. Okay, so this means repeat the letters of key so that number of letters of plain text and key becomes equal. Okay, now see at the slide. In this slide we have a first letter that is give. We have a first letter that is G in the plain text. In the plain text, where is G? This is G. And key, the first letter of key, that is L, lock. Okay, L, where the first letter of key and first letter of plain text intersect. Okay, first letter of key and first letter of plain text intersect. That is our required letter. That is our required letter. So this means G is replaced with R. This means G is replaced with R. Okay. Next we have I. Next we have I. In the plain text, in the column side, we will see I, and in the column, in the row side, we have a key, and the letter of key is O. Okay. Now O and I, where intersect both, that points our required point. Okay, that is W. That is W. So this means next letter I is replaced with W. Okay, in this way we convert all these plain text letters into the cipher text letters. Okay, and give money becomes that is R W X O X C P O J. Okay, this is our cipher text. Okay, we in the column side we have plain text. In the row side, in the table, we have a key. Both the letters intersect at a particular point. That point is our required cipher letter. Okay, so G and L intersect at letter R. So G is replaced by R. I and O intersect at letter W. So I is replaced with W. V and C intersect at a point X. So V is replaced with X. Okay. Next, E and K intersect at a point O. So E is replaced with O, and so on. In this way, Wagoner tables work, and you can convert the plain text into the cipher text by using this method. Okay. In the reverse, if you want to convert from cipher text to the plain text, the same procedure is followed. But at the place of plain text, we will use cipher text. We will use cipher text. Okay, in this way. The cipher text is R W X O X C P O and J. Okay. Now, how to convert this cipher text into the plain text? See at the column side in the table. For in this case, firstly we see the key letter. First key letter is L. So L, and in the cipher text we have letter R. So in the L, move to right and find the letter R. Okay, here this is R, and R corresponding to R in the plain text is G. Okay, is the G letter. Okay, in this way, next letter in the key is O. And cipher text letter is W. So in the row of letter O, move to the right side and find the letter W. Here it is the W, and corresponding to W in the plain text is I. Okay, is the letter I. Okay, in this way you can find, or you can convert the cipher text into the plain text again. Okay, it is very simple. It is very simple to solve the questions of a beginner cipher. Okay, in this way you can convert plain text into the cipher text and cipher text into the plain text by using this table. And I also had explained in the previous lecture how to make this table. It is very easy to draw the table. See, at the column side, we write all the alphabetical letters A to, we write all the alphabetical letters A to Z. Okay. In the row side, we also write all the alphabetical letters A to Z. Okay. We pick the first letter from column side and row side, A, and write all the alphabet letters from A to Z. This is our first row. Okay. In the second row, we have a B. Okay. Start from B, write all the alphabets to the right in the table. And last cell is fitted with letter A. Okay, repeat the letters at the last. Okay, and third alphabet is C. So write starting from C letters onwards to the right, and all the letters starting from C from left to right. Okay, Z. Then add A, B. Okay, it is circular, it is circular right. Okay, in this way this table is formed. Okay, this is about Wagoner cipher. Now the next is Hill cipher. Hill cipher. Next is Hill cipher. Hill cipher is also important, and in this cipher we use matrix concept of matrix. Okay, in this we convert the key into matrix form, and also plain text into the matrix form. Okay, firstly we have to convert the key into matrix form. It may be a 2 by 2 matrix, or it may be a 3 by 3 matrix. Okay, so we call it polygraph. Polygraph means it is of 2 by 2 matrix, or 3 by 3 matrix, 4 by 4 matrix. It may be any matrix. It may be any matrix. It is 2 by 2, 3 by 3, 4 by 4 matrix. So that's why it is called polygraph matrix. Okay, in Hill cipher, developed by Lester Hill in 19, developed by this technique developed by Lester Hill in 1929. Okay, and encrypt the group of letters called polygraph. So here we have a polygraph of a 2 by 2 matrix or a 3 by 3 matrix. Okay, and in Hill cipher, for converting the plain text into cipher text, we have a formula, that is for encryption. For encryption, we have C is in this technique. We use only the encryption technique. Okay, so C is equal to KP mode 26. What is C? C is the cipher text. K is the key, and P is the plain text. Plain text means original message. Plain text means original message. Okay. Here, let's start with the example how the Hill cipher works. Let us suppose, firstly choose a key. In this, a very important thing is that is key. Firstly, we have to choose the key. Let us suppose if we have a key is equal to view. If we have a key view in this form, then you have to convert this key into matrix form, and it is of square matrix. Okay, it is of square matrix. Okay, so this means VIE view should have to convert into the matrix form. How to convert this view key into the matrix form? Like this: VIEW, view. Okay, now write the corresponding letter numbers. What is What is the letter numbers of V? That is of 21, and letter number of I is equal to 8, and E 4, and W is equal to 22. How to write letter numbers? I told you in the previous lectures. A 0, B 1, C 2, D 3, 4 in this way, and Z is equal to 25. This is, in this way we assign the numbers to the letters. Okay, we just write the numbers of these letters in the matrix form. Okay, so in this way you have to convert the key view into the matrix form. Let us suppose if we have a key like this. Quickness. If we have a key of letters, that is quickness, and how to convert this key into matrix form, we can write like this: Q U I C K N E S S. Quickness. It is of 2 by 2 matrix. It is of 3 by 3 matrix. Clear? So in this way you can convert the key into matrix form. Also you have to write the name, write the numbers of these letters. Numbers of these letters. What is the number of Q? Letter number of Q is 16, and U 20, I 8. Okay, in this way we have 2, 10, 13, 4, 18, and 18. In this way we can convert the key into the matrix form. Okay, so this is the concept how to convert the key into the matrix form. It is a very important. We have to convert the key into a matrix. Now, second thing, plain text. No, plain text. In plain text, we have to make the vector of length. The vector of length 1. The vector of length 1 means it may be a 1 row or 1 column. Okay. If we have 2 by 2 matrix, if we have n into n matrix, n into 1, this is the for key, this is for plain text. Okay, this is for plain text, and we have to form pair. We have to form pair. Okay, let us suppose if we have a plain text attack, ATTACK attack. Now, and we have a key of 2 by 2. Key of 2 by 2. Okay, and in this way we have 2 into 1 form of plain text of vector 1. Okay, now you have to convert this plain text into in the vector form. So how to write is, we will write like this: A T T A C K. Okay, in this way you will convert the plain text into the form of vector. And हमें कैसे पता चलेगा इसको दो की फॉर्म में लेना? It depends upon the key. It depends upon key. If we have, ये देखो, n by n, if we have n is equal to 3, this means n is equal to 3 means we have 3 by 3 matrix of key, and the vector of is also of 3 into 1, means how to and then we will write the plain text in the form of 3 by 3 like this: A T T A C K. Okay, in this way. Okay, next let us take an example how it works. Hill cipher, how Hill cipher works. Let us suppose, so write down, since the key is a 2 into 2 matrix, plain text should be converted into vector of length 2. If key is of 2 by 2 matrix, then plain text should be converted into vector of length 2. Should be converted into vector of length 2. So let us take an example of Hill cipher. Hill cipher. Okay, let us suppose we have a plain text is equal to attack. Okay, and we have a key is equal to 2336. If we have a key like this, well and good. If you have letters in the key, firstly you convert these letters into matrix form. Okay, and then write the letter numbers in the matrix. Okay, clear? Okay, so now we have a plain text attack, and this is our key. Now you have to perform by using Hill cipher, convert the plain text into the cipher text. How it works? We have a formula for encryption. For encryption, we have a formula C is equal to KP mod 26. Okay, K is the key, P is the plain text. Now convert this plain text into of length 2, because of length of 2, because we have a key of 2 by 2. So convert this A T T A C K. Clear? Firstly, we convert. So first vector is equal to AT. So the first vector is AT. Okay, put this value in the formulas, that is we have, and this A is equal to, in the number form, A is 0 and T is 19. Okay, firstly convert the first vector into number form. The corresponding number of A is 0 and the corresponding number of T is 19. Clear? So write key is 2336. This is key, and now we have plain text. The first vector is 0 and 19 mod 26. Now solve this. Multiply this row with this column, this row with this column. Okay, 2 into 0 plus 3 into 19. Okay, next 3 into 0 plus 6 into 19 mod 26. Now we have 0 plus 57, 0 plus 114 mod 26 is equal to 57, 114 Mode 26. Okay. After solving this, mode 26 means we have to calculate the remainder. We have to calculate remainder. Okay. After calculating this, we will get 5 and 10. 5 and 10. And what is the corresponding letter of 5 and 10? Corresponding letter 5, we have F, and 10 K. K. Okay. In this way, we have to convert AT becomes F K. A key becomes F K. Or you can say AT becomes F K. This is the conversion of first vector, that is AT. Now you have to convert second vector into ciphertext and third vector into ciphertext, and then combine all the result of three vectors and you will get the ciphertext. Okay. Hurry up, complete this example. Now calculate second vector. Now calculate for second vector. Second vector is T A. Second, what is second vector? Vector, that is T A. Now firstly convert this T A into the form of numbers. Then use this formula. Put the values of key and second vector and solve this and tell me the result. Okay, tell me the result. Yes, Simranjeet saying only we consider only square matrix in Hill cipher. Okay. Yes, Anjali Singh, we always consider square matrix. No, Anchal Mitra, it is in the form of n into 1. Okay, it is the form of n into 1. Clear? We have to multiply the key with the plain text vector. So it should be n into 1. Clear? जो सिमरनजीत सिंह जो 5 और 10 है ये कुछ भी नहीं है. इट इज जस्ट अ रिमाइंडर ऑफ लिसन. देखो here we have 57 and more 26. 26 into 26 into 2 is equal to 52 and we have remainder 5. So write 5. 114 26 मल्टीप्लाई करो इस नंबर के साथ कि वी हैव रिमाइंडर ऑफ 10. ओके, इन दिस वे वी हैव टू कैलकुलेट मोड 10. ओके, yes, exactly the result for vector 2 TA is MF. मनप्रीत सिंह बिल्कुल सही है. ओके, MF. Okay, in this way you can convert the plain text into the cipher text. For second vector, we have a result T A becomes M F. Okay, third vector, for third vector, that is CK, it becomes CK, it becomes IO. It becomes IO. And the cipher text for attack, and the ciphertext for attack is FKMFIO. Okay. In this way, you can calculate or you can convert the plain text into the ciphertext by using Hill cipher. Easy है, बहुत easy है. Okay. Madhav Vijay, for CK is OO. No. For CK it is IO. Check it. Okay, in this way you can convert cipher plain text into the cipher text. Okay, solve this example. Now, if you have another example of Hill cipher, that is, we have a plain message that is of short message, and key is Hill. Key is Hill. Okay, this is the second example. Okay, solve it yourself. Okay, and okay, all these till now, whatever the techniques we have done, that comes under substitution cipher. That comes under substitution cipher. Okay. Now, in the next topic, we have a transposition technique. We have transposition technique. We have transposition technique. What is transposition technique? How it works? What is the concept of transposition technique? Next is transposition technique. Next is transposition technique. In this technique, we also convert plain text into cipher text, but not with the substitution. We reorder or we rearrange the letters in the transposition technique of plain text. Okay. In transposition technique, we reorder or rearrange the letters in the plain text. Let us suppose if you have A, B, this is our plain text. Now we have to convert this plain text into the cipher text. Then you have to rearrange these letters. That is the concept of the transposition technique. We can write B, A in this way. Okay. We do not substitute letters in place of A or B. We just reorder or rearrange the letters in the plain text. And whatever we get, that is the cipher text. Okay. Let us suppose if you have A, B, C, then you can convert it B, A, C, C, A, B, A, B, C, B, like this. Okay. You reorder or rearrange the letters by some sort of permutations. Okay. Then whatever we get, that is the cipher text. That is the cipher text. And this is the concept of transposition technique. And this is the concept of transposition technique. Transposition techniques means no replacement of characters. वही जो मैंने अभी बताया आपको, दैट इज ट्रांसपोजिशन टेक्निक मीन्स नो रिप्लेसमेंट ऑफ कैरेक्टर, नो रिप्लेसमेंट ऑफ characters. Second point is we rearrange the characters position. We rearrange the characters position. Okay, this is the concept of transposition technique by some sort of permutations. Okay, by some sort of permutation. Okay, now transposition technique is of two types. Basically, we have we can say it is of three types. One is rail fence, second is columnar, and third one is double columnar. And we also have keyed and keyless, and keyed transposition technique. We also look at this. Firstly we will do first type of transposition technique, that is rail fence. Rail fence technique. Rail fence technique. Okay. The concept is very easy. In this rail fence, we write the plain text. We write the plain text in the diagonal form. In the diagonal form. Let us suppose, for example, the concept is very easy. What is the concept of rail fence? Write the plain text in the diagonal form and then read the letters in the row form. That is our ciphertext. For example, if we have a plain text, all the best for exam. All the best for exam. Okay, this is our plain text. Then how to convert this plain text into ciphertext by using rail fence technique? The technique is simple. Write this plain text in the diagonal form and then read the letters in the row form, in the row wise, in this way. If you write A, L, L, all, T, H, E, D, B, E, S, T, best, F, O, R, for, E, X, A, M, S, exams. In this way, in the diagonal form, or you can say in the zigzag form, Now, how to read this? Or how to convert, how we get the ciphertext from this? Now, just write first row and then second row. It is of depth 2. Why it is of depth 2? Because we have only 2 letters diagonals. If we have 3 letters, A, L, L, that is of depth 3. If we write like this, that is of A, L, L, that is of depth 3. Now here we have depth 2. Okay, now convert this into the ciphertext, that is A, L, H, D, S, F, R, X, M. Then start from there, here, L, T, E, E, T, TOCAS. This is the cipher text by using rail fence. In this way, you will convert the plain text into the cipher text by using the concept of rail fence. In rail fence technique, we write the plain text in the form of diagonals and read the letters row by row. Okay, row by row. Okay. So it is very easy and it is used for short message, and the problem is this message can easily be hacked, or you can say easily attackers can easily look the message, original message. Okay, in this way it is very easy to break. It is very easy to break. In this way, rail fence technique is work. Okay. Is it our choice to select the depth? Oh, yes, Abhinav, yes, you can give the example of any depth. Okay, it's not specified in the question. Sir, in this example, why we are not using depth? वैसे ही ऐसा कुछ नहीं है अंजलि सिंह कि हमने डेप्थ क्यों नहीं यूज किया. वी जस्ट यूजिंग द डेप्थ ऑफ 2. वी आल्सो कैन यूज द डेप्थ ऑफ 3, नो प्रॉब्लम. Gursevak Singh, you do not consider the spaces. You just write the whole message in the running form. ये spaces को हमने कुछ नहीं कहना है. We just write इसको हमने सिर्फ एक ही लाइन कंसीडर कर. Clear? Yes, Anjali, you can choose any depth 2 or 3, or it may be given in the question. Okay, convert the for example, convert the plain text into the cipher text by using rail fence and by using the depth of 3 or depth of 2. Okay. At the end, if you have not a letter, तो उसको छोड़ दो वैसे. Or you can insert dummy bit. Or you can insert dummy bit. Aditya Sharma, we are not using key in rail fence. Rinder Joshi, no problem. If there is no S at the last, you can write. इसको छोड़ दो, ऐसे छोड़ दो. If you have exam, इसको ऐसे लिख दो. या फिर you can insert dummy bit, any dummy bit X. Okay. Clear? Okay. So the next is row transposition cipher. The next topic is row transposition cipher. Row transposition cipher. Second type of transposition technique is row transposition technique, or you can say columnar transposition technique. COLUMNAR, columnar transposition technique. Okay. In this method, row transposition cipher technique, in this method, we write the message in rectangle form, or you can say row by row, or you can say row by row. Write the message or plain text row by row and read the message in column by column. Write the plain text by row by row and read message by column by column. Okay, whenever you write the plain text in row transposition, what is the concept is write the plain text in row by row, okay, and read the message column by column in the row transposition. Okay, here it is of rectangular form. It is of rectangular form. So you can say we write the message in rectangle row by row and read the message column by column. But permute the order of columns. Order of columns. What does it mean? This means we have to shuffle the columns. In this technique, row transposition techniques, we have a key. We have a key of integer. We have a key of integer value. Let us suppose if, for example, 4, 3, in this way, or you can say 4, 3, 2, 1, okay, in this way, okay, this is key. But if you have key like this, crypto, CRYPTO, but our requirement is key should be in integer form. That is our requirement in row transposition. But here we have a key in the form of letters. Now you have to convert this letter into integer form. How to convert this key into the integer form? In this, we decide by the alphabet order of letters in the key. Alphabet order of letters in the key. Let us suppose in this key, first letter is, that is C. मीन्स कि ABC में हमारे पास सबसे पहले लेटर कौन सा आता है? इसमें जो भी ABC में पहले लेटर आएगा, that is our first number. For example, if we have crypto, this means in this we have alphabet. Consider the alphabet order. So C comes first. So it marks as 1. So C is marked as 1. So C labeled with 1. After C, what letters comes next? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. Next letter comes O. So O is labeled as 2. After O, which letter comes next? M-N-O-P. M-N-O-P means P is labeled as 3. Okay, listen carefully. How to convert this letters into the key in case of row transposition technique. Then after P, which letter comes next? M-N-O-P-Q-R. R is labeled as 4. After that, we have T, that is of 5. And in the last, we have Y, that is 6. And this is our key. 146352 is the key. Is the key. It is the key. Okay. Clear? How to convert key into integer value? In this way, you can convert key in the integer value. Clear? Any doubt? हाँ जी स्टूडेंट, चले? क्लियर? Okay. Let us suppose example. Let's take an example of row transposition technique. Row transposition technique. The example is we have a plain text attack postponed until 2 a.m. This is our message. Attack postponed. Attack postponed until 2 a.m. Okay, this is our message, and we have a key. Let us suppose we have a key is 4 3 1 2 5 6 and 7. Here the key is given. Here the key is given. In this example, key is given. Okay, we have a key 4 3 1 2 5 6 7. This is our key. Now this is our plain text. Plain text means the original message. Now you have to write this message by using columnar transposition technique. Convert this message into the cipher message. Okay. Now how to write this message in the okay. Now write this message in the row form. What I told you, okay, row transposition works on the basis of insert the columns row wise and read the message in the column wise. Okay, so firstly we have to write the message in the row wise and then read the message from the column. Okay, so let's write this message. So we have attack ATTACK POSTPONED postponed until 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 2 TWOAM. Okay, what is the concept of row transposition? Write the plain text in row wise. Okay, it should be a rectangular. It should be a in the form of rectangular. ATTACK attack POSTPONED postponed UNTIL until TW2AM. Okay, in this way you can write the plain message in rectangular form. Okay, now we have 3 spaces left. You can leave it as it is, or you can insert dummy bit. You can insert dummy bits X, Y. You can also insert dummy bits. Okay. ये तो हो गया, हमने मैसेज लिख लिया हमने रेक्टेंगल में. Now we have to convert this message into the column. Now we have to convert this message into the cipher text. Into cipher text. Into cipher text. How to convert it into cipher text? We have to read message column wise, starting from 1, 2, 3, 4 in sequence of letters. Firstly, we read from 1, that is T, T, N, A. We read this column first, and after that we will read the column this. After 1, we will read the column of second 2. Okay, 2. Read this message as it is in the form of column A P T M. A P T M. Okay. After this, we will read the column of labeled 3. This 3. T S U O. T S U O. Okay. After this, we will read the message of column this one of labeled 4 column A O D W. A O D W. Clear? And after 4, we will read the column number 5. This one C O I X. C O I X. Okay. Then 6 K N L Y. Then 7 P E T Z. P E T Z. This is our cipher text by using row transposition technique. By using row transposition technique. In this way, we can convert plain text into the column form. Plain text into the cipher text. In this technique, firstly we write the plain text in the by row. Okay. Then read the message column by column and write it. And that is our cipher text. Okay. Now I am going to launch. इसका आगे और भी अभी बताता हूँ मैं बाद में. Firstly, I'm going to launch poll first. Poll 1. You have 5 minutes for it. Okay. आंचल मित्तल, ये तो मैंने आपको बताने के लिए स्पेस दी है. ओके. अदरवाइज इट इज अ सिंगल मैसेज. नो, देयर विल बी नो अ स्पेस इन वन वर्ड. ओके. Aditya, key should be secure. ये 5 नहीं होगी, जहाँ तो होगी वो 4, 6 इन दिस वे, जिससे हमारा 2x2 का मैट्रिक्स बन जाए, 3x3 का मैट्रिक्स बन जाए, 4x4 का मैट्रिक्स बन जाए. इन दिस वे वी विल चूज मैट्रिक्स. Oh, sorry, key like this. Okay. Aditya Sharma. Ji students, any question? Students, you have only 2 minutes, so hurry up. जिन्होंने नहीं किया था और जिन्होंने कर दिया था, all the students have to submit your answer. ओके मैंने रीलॉन्च किया है तो प्रीवियस डेटा सारा वो सबमिट नहीं हुआ है, तो यू हैव ऑल द स्टूडेंट्स हैव टू सबमिट देयर आंसर्स अगेन. ओके यू हैव 3 minutes. ओके कर लिया सभी ने? यस और नो? Last 30 seconds, hurry up. Okay, students, I am going to end the poll 1. You all have done? Yes or no?
Yes, sir.
Okay. Okay, students, next is this is our row transposition technique. Row transposition technique or columnar transposition technique. Okay, now if you again perform row transposition technique on ciphertext by using this method, that is called double transposition of technique. Now here we will not use this message plain text, we will use ciphertext message, write row by row, and after that read message column by column. Okay, this means we perform row transposition technique twice. Firstly, we perform row transposition technique on plain text. After that, we perform transposition techniques on ciphertext message. And after that, you will get output. Okay, so do it, hurry up. Fastly, इसको complete करो, जितनी जल्दी हो सके इसको complete करो. Hurry up. That is called double transposition technique by using same key. In this way, you can use key. You may use a same key or different key. Okay, so in double transposition technique, ciphertext applied row means columnar transposition or row transposition. Cipher applied twice. Second point is key in second case. In this case can be same or different. Key can be same or different. Okay, in this way, Now you will use this message in at this here, okay, and after you will read first, second, third, fourth, fifth, second, and 7 column in this way. Okay, hurry up, jaldi karo और मुझे cipher text बताओ. What will be the cipher text? Kamlesh, unmute yourself.
यस सर. सर लास्ट जो डबल ट्रांसपोजिशन है उसको रिपीट कर देते हैं.
ओके ओके. आवाज आ रही, सबको क्लियर आ रही है आवाज? ओके. नो स्टूडेंट्स, सेकंड इज नेक्स्ट इज डबल ट्रांसपोजिशन. इन डबल ट्रांसपोजिशन, फर्स्टली we will perform row transposition on plain text. Okay, now performing a row transposition technique on plain text, we will get this cipher text. Now again you have to apply row transposition technique on this cipher text and you will get another result that will be the also the cipher text. With this you have more secure data, more secure message, more secure cipher text message. Okay, in this way. Now we will use this message TTNA AP TM TSUO AODW COIX. Okay, KNLY PETZ. Okay, now read this message. Now you have to write from the label column labeled as 1. Read from this. Now the next output will be NSCY. Next column of labeled 2. AUOP. Next is third TTWL, and so on. This is called double transposition technique. This is called double transposition technique. Okay. Okay, so you can do double transposition like this. Okay, I hope कर लोगे ना आप लोग. फिर भी कोई doubt हो तो you can ask me. Okay. Next, as I told you, transposition technique is also of two types, that is key technique and keyless. Keyless and key technique. Keyless and key technique. Okay. Firstly, we will do keyless. Transposition is also of keyless and key technique. Keyless is of real fence. In real fence we have not used key, any key. So that is of type real fence. Keyless is of real fence. Okay, तो ये करवाने की जरूरत नहीं है कि जो हमने real fence किया that is of keyless. Second is keyed transposition technique. In this we will use a key. Okay, on the basis of key, we will convert the plain text into the cipher text. Okay. In we have a method in keyed transposition technique. We convert the plain text message into blocks of particular size. We convert the plain text into blocks of particular size or predetermined size. Clear? In this keyed message, we convert the plain text into blocks of predefined or predetermined size. Okay, blocks जो message होता है blocks में convert कर देता हूँ, which is of 3-letter blocks, 4-letter blocks, 5-letter blocks. It depends upon the sender and transmitter. Okay, it is concerned with the sender and of the receiver, which size of block they want to use. Okay, let us suppose if we let's take an example of keyed transposition technique. Let us suppose if we have two persons, Alice and Bob. They want to send secret message between them by using keyed transposition technique. Alice needs to send a message, enemy attacks tonight. Alice want to send a message, enemy attacks tonight, to the Bob. Enemy, E-N-E enemy attack tonight. This is the message, enemy attack tonight. Alice want to send to the Bob. Okay, and Alice and Bob have agreed to divide the text into groups of 5 characters. Alice and Bob has decided to convert the message into blocks of size 5 characters. इन्होंने क्या डिसाइड किया कि जो हमारा मैसेज उसको 5 कैरेक्टर्स में सेंड करेंगे एक दूसरे को. ओके, सीक्रेट है, दोनों में सीक्रेट है ये. ओके, एंड देन परम्यूट कैरेक्टर्स इन ईच ग्रुप. हर एक ग्रुप में हमने क्या करना है, उनको रीअरेंज करना है, रीऑर्डर करना है, परम्यूट करना है. ओके, so firstly we will convert this message into groups or blocks of 5 letters. E-N-E-M-Y, enemy, attack, A-T-T-A-C-K, attack, tonight, T-O-N-I-G-H-T, tonight. This is our plain text message. Firstly, we convert this message into blocks of size 5 characters. E-N-E-M, 1, 2, 3, 4, 5. Enemy, ठीक है, A-T-T-A-C. This is our first block. This is our second block. Next block, K-T-O-N-I. This is our attack, K-S-T-O-N. This is our third block. Next block is I-G-H-T. This is our last block. Now here we have only 4 letters, but Alice and Bob had decided to convert the plain text into of size 5 characters. But here in the last block we have only 4 characters. So here we will insert a dummy bit, that is of any dummy bit that is of Z, we will consider Z. Okay, so this is also of 5 characters. Now they have both Alice and Bob have a key. की, सिक्योर की, बिटवीन दोनों को पता है कौन सी की है, उन्होंने डिसाइड किया कि ये हमारी की होगी. सो द की इज, so the key is 3 1 4 5 and 2 and 1 2 3 1 2 3 4 5. Downward encryption, upward decryption. Okay, what does it mean? This means let us take first block, that is enemy. E N E M Y, and let's number these letters as 1 2 3 4 and 5. Okay, we number this letter like this. Okay, now for encryption, this means the letter third is replaced with it, letter third is exchanged with letter 1. Letter third is exchanged with letter 1. Okay, this means third जो letter है उसको हमने कहाँ पर लेकर आना, फर्स्ट, सॉरी एक्सचेंज नहीं करना हमने, सॉरी, लेटर थर्ड को हमने फर्स्ट पोजीशन पे लेकर आना. Okay, this means this letter E is placed at position first, that is E. Next, first letter or character placed at position 2. First character, that is E, is placed at position 2, means this here. Okay. Next, letter 4, that is M, is placed at position 3rd. Letter 4, that is M, is placed at position 3 here. Yes, यहाँ पर. Okay. Next, letter 5, fifth letter, that is of Y, is placed at position 4 in this way. This is Y. Okay. Next is letter 2, that is N, is placed at position 5. Is placed at position 5 in this way. E-E-M-Y-N. E-E-M-Y-N. Student, any problem? Board is visible to all of you? Okay? ब्लड आ रहा है. अब ठीक है? अब ठीक है? क्लियर नहीं आ रहा बोर्ड? साफ नहीं आ रहा है. अब ठीक है स्टूडेंट्स? देखो इतना थोड़ा सा शायद पता नहीं क्या प्रॉब्लम आ रही है, तो एडजस्ट कर लो, बाकी फिर देखते हैं। थोड़ा सा ये बस हमारा बोर्ड का काम बस ये लास्ट ही है। ओके, ये जस्ट ये पता चल गया कैसे कन्वर्ट करना है, की को कैसे यूज करना है, हाउ टू यूज दिस की बाय कन्वर्टिंग द ब्लॉक्स इनटू द साइफर टेक्स्ट। यस और नो? हाँ जी स्टूडेंट्स, यस और नो? माधव, वन म्यूट योरसेल्फ।
सर एक बार ये टेबल वाला एक्सप्लेन कर देंगे?
ये वाला
ये टेबल जहाँ पे आपने एनक्रिप्शन के लिए डाउनवर्ड बताया और डिक्रिप्शन के
ओके
लिए।
ओके ओके। Okay, I'm going to explain again how to convert the plain text into the cipher text. Just we have a key. This is our key, and we take first block. Let's take the first block. That is E N E M Y N. Now let's for our simplicity we mark these letters as 1, 2, 3, 4, and 5. Now, letter number 3, that is of E, is placed at position 1. Letter number of 3 is placed at position 1, means here, E. Next, letter number first position letter, that is E, placed at position 2, that is here. Okay, next letter number 4, that is M, is placed at position 3 here. Place M here. Clear? Okay. Next letter number 5, that is Y, is placed at position 4 here. In the last we have 2. Letter number 2, that is N, is placed at position 5 here. That is N. Now the encrypted form of enemy is EEMYN. This is the encrypted form for enemy. Okay. In this way, you have to convert next block in the second encrypted form, then third block, then fourth block. In this way, you have to convert these blocks into the cipher text. Clear? First block enemy is replaced with these letters. Next, ATTAC. ATTAC. 1, 2, 3, 4, and 5. Letter number 3 is placed at position 1. Letter number 3, that is of T, is placed at position 1 here. Second, letter number 1, that is A, is placed at position 2, means here. Okay. Next, letter number 4, that is A, is placed at position 3. So place it at position 3 here. Okay. Next, letter number 5, that is C, is placed at position 4, means here. C. Letter number 2, that is T, is placed at position 5. Now, the encrypted form for ATTAC is TAACT. This is the cipher text for second block TATTAC. In this way, you have to convert the remaining 2 blocks and complete this message and message me the result. And I have, so write for the third block, the output will be KSTON. The output for third block KSTON is, write down TKONS, TKONS, and for fourth block IGHTZ is HITZ, HITZ. Okay, this is for second block. Okay, in this way you have to convert this message into the ciphertext. Okay, this is the concept of keyed transposition technique. Okay, okay, students, and next topic is steganography. Steganography. It is very simple. Steganography concept is very easy. In this, we hide the message into the cover file. Okay, it has steganography is derived from two Greek words. Stegnos means to cover, and graphia means writing. Thus, translating to covered writing or hidden writing. Okay, in this in steganography, we have to hide our secret message into covered file. Okay, into the covered file. Okay, steganography is a method of hiding secret data by embedding it into video, image or text file. इसमें क्या होता है, सीक्रेट मैसेज जो होता है ना, उसको हम किसी टेक्स्ट फाइल में, वीडियो फाइल में, इमेज में, किसी में भी उसको हाइड करके वो हम ट्रांसफर करते हैं सेंडर को, रिसीवर को, सॉरी, हाइड करके. लेट अस सपोज वी हैव अ डायग्राम कवर फाइल. Okay, second is we have a secret message M. No, by using the steganographic encoder means we apply the function on cover file and secret message. We have to get the stego object. Stego object. Okay? In the steganographic encoder we apply the function, steganographic function, that is F. X means cover file, M means secret message, K means key. Okay, and we will get the message stego object. Like this, firstly we convert the plain text into the cipher text. Okay, and stego object is just like a hidden message. Okay, and then through the communication channel, stego object transferred to the other end. Steganographic decoder, by using a steganographic decoder, we access the secret message. We access the secret message from the cover file. Okay. वही जो मैंने अभी आपको बताया वही लिखा है. Then we have a few differences between steganography and cryptography. So you can see, I will send you this PPT to you, and you can read these differences. Now, types of steganography. We have various types of steganography: text steganography, image steganography, video steganography, audio steganography, and network steganography. So no need to explain further these types. You just remember these types, various types of steganography. Text steganography means we hide the secret message in text file. Okay. Image steganography means we hide our secret message in the image and send it to the receiver. Then video steganography means we will hide our secret message in the video, and then we have to send that message. Then audio steganography means we have to hide the message in audio steganography and then send it to the receiver. And after that we have network steganography. Network steganography, in that we use various TCP/IP models, and we have to we insert our secret message in TCP. Suppose a TCP/IP header, we submit a secret message that header and then send it to the receiver. Okay, and no need of further explanation of these types. You just remember these types name. Okay. So it is a very easy topic. Steganography means we have to hide our secret message in a video, text, audio, or network. Okay. After then we can send our secret message. Okay. This is about steganography. And at the last, we have a router machine. We have a router. Before going to router machine, I'm going to launch poll second. You just have 5 minutes. Okay, you have only 5 minutes for poll 2. After 5 minutes, I automatically end the poll. Okay, so your time starts now. Any doubt, any question, students? जल्दी करो पोल, मैंने ये नेक्स्ट टॉपिक करवाना है आगे रोटर मशीन का. आज हमने टेक्निक्स फिनिश करनी है बिकॉज हमारा जो सिलेबस है वो बहुत ज़्यादा है, तो सो वी हैव टू लविश अनम्यूट योरसेल्फ.
सर पोल विजिबल नहीं है.
क्यों?
पता नहीं सर.
आ रहा है पोल.
पिछले वाला तो आया था, ये नहीं विजिबल.
नहीं आ रहा है, सबको आ रहा है.
स्क्रीनशॉट भेजूं आपको?
नहीं, स्क्रीनशॉट क्या करनी है, विजिबल है सबको.
सर मुझे विजिबल ही नहीं है, तभी मैंने हैंड रेज किया.
आपके नेटवर्क, आपके एंड पर नेटवर्क की प्रॉब्लम ना हो, रिफ्रेश करो.
नेटवर्क की प्रॉब्लम नहीं है सर, बिल्कुल नहीं है.
ये यहाँ पर मैंने लैपटॉप और कंप्यूटर भी खोला हुआ, वहाँ पर तो हो रहा है विजिबल, सारा कुछ हो रहा है. रिफ्रेश करो एक बार. Okay, students, done? हेलो.
हाँ जी सर, नहीं हुआ.
क्या प्रॉब्लम हो सकती है फिर? यहाँ तो आ रहा है यार, सारे आ रहा है। चलो देखते हैं।
ठीक है सर, थैंक यू।
Okay, students, I am going to end poll 2. I hope you all of submit your result. Yes or no? Okay, students, I am going to end poll 2. Okay, the next and last topic of our classical encryption techniques is router machine. Okay, it is basically a machine of multiple stages of encryption. Okay, in this we have a various number of cylinders. We have various cylinders which rotates after striking one key. If we press a letter A, it rotates one shift to the down, Okay, in this we have a number of cylinders, like we have 4 cylinders, 1, 2, 3 and 4, consist of number of cylinders. Okay, and each cylinder consists of 26 inputs and 26 outputs. Each cylinder consists of 26 inputs and 26 outputs. Okay, like this. 26 inputs and 26 outputs. Yes, and each input is associated with alphabet. Okay, each cylinder has 26 input pins and 26 output pins, and each pin is associated with a letter, alphabet. Clear? Each input is internally connected to an output, like this. Each input is internally connected to the output. Okay, let us suppose, for example, letter A, that is pin number 1, that is connected with here. If I press A, its output will be, this is 1, this is 1, this is 1. If I press A, its output will be L. If I press B, its output will be R. Okay. Now in this way we can convert our letters to the cipher letters. Okay. Here we have an example. If input A, if I press input A and its output will be L. Now, for example, if we have plain text P, A and D, if we have a plain text P is equal to A and D, then cipher text will be L, U, B. A is replaced with L, N is replaced with U, D is replaced with B. Okay, in this way. If we have, for example, like D is of letter 4. 4 is D. If I press D, its output will be D. So it is used for replacement of letter. Clear? These cylinders will be rotating after each keystroke. It will make a shift. These cylinders will rotating downwards. These cylinders rotating downwards. If I press A, it rotates downward by one shift. Let us suppose if I press A, okay, in the next stage, A is labeled with 26. A is labeled with 26. A is labeled with 20. If I press A, it moves to downward by one shift. It moves to downward by one shift. So B is labeled by 1 and A is labeled with 26 after each keystroke. Okay. For example, if we use just one cylinder, it will give us a secret message. But if we want to improve our security, then we have to use number of cylinders. Okay, and each cylinders are connected with each other. Clear? So to improve the security, we use multiple number of cylinders, and the output of one cylinder will be connected to the input of the next cylinder. Clear? Like this. This is our input. This is the output of cylinder 1. Output of cylinder 1 is connected to the input of cylinder 2. Output of cylinder 2 is connected to the input of cylinder 3. This is internally connected with the output pins, and this is the output. Okay, if I press A, that is of 26. That is of 26. 26 equal to 18. 18 pin. 18 is equal to 18. And 18 will be the equal to V. Okay, if I press A, our output will be V. This is more secure as compared to one cylinder. Like this. If I press A, the pin number is 26. Its output is 26 because this A is connected to the output pin, and this output pin is connected to the second cylinder. The pin number is 18, and output of cylinder 2 is connected with the output of cylinder 2, 18, pin number 18, and this 18 is connected with 22, and the output of this 22 line will be the 22, that is of K. If I press A, then the secret message will be the K. Okay, so A is converted into the K. In this way, our rotor machine is worked. It is also used for the purpose of encryption, and we can, with the router machine, we can make encryption with at multiple levels. Okay, जितने ज़्यादा हमारे पास सिलेंडर उतना ही ज़्यादा हमारे पास सिक्योर क्या होगा, हमारी आउटपुट होगी. नो जस्ट आंसर वो हमने सिर्फ एक सिलेंडर की बात की थी कि एक सिलेंडर जो है वो ये देखो, इसमें मैंने ए प्रेस किया, ए क्या हो गया, हमारा नीचे को मूव किया. ठीक है, ए वहीं पर रहा, लेकिन उसकी पोजीशन चेंज हो गई, कि जो पिन नंबर थी वो चेंज हो गई है. पिन नंबर पहले इसकी 1 थी, आफ्टर 1 की स्टॉक पिन नंबर ऑफ ए इज 26, इसकी बन गई 26, बी की बन गई 1, वो नीचे को मूव करती. इसी चीज को हमने नेक्स्ट ये वाली सिलेंडर को हमने यहाँ पर आफ्टर 1 की स्टॉक हमने यहाँ पर शिफ्ट, आफ्टर 1 शिफ्ट को हमने यहाँ पर रिप्रेजेंट किया. ठीक है, in next lecture I will also explain it. Before starting the next topic, I explain this topic again. Okay, बिकॉज नो टाइम इज ओवर। ठीक है, टाइम हो गया तो हम नेक्स्ट लेक्चर में आपको इसके बाद आपको एक बार फिर से ओवरव्यू दे दूंगा। ठीक है जी, ओके ओके। ये दीज आर आवर क्लासिकल टेक्निक्स which are used in encryption and इनको अच्छे से पढ़ लेना। अब इसकी टेक्निक्स हमारी खत्म हो गई है। नो आई विल सेंड यू ऑल दी नोट्स, यहाँ तक कि आपको सारे नोट्स मैं जो है वो सेंड कर दूंगा। ठीक है जी, ओके। सो नो यू कैन लीव द मीटिंग। अभिनव, अनम्यूट योरसेल्फ।
सर पोल क्वेश्चन के आंसर्स
वो भी दे दूंगा, क्या करना है आपको, भेज दूंगा मैं आपको।
सर वो एक्चुअली फिर पता लग जाता है कि कौन सा क्वेश्चन हमने ठीक किया है, कौन सा किस में कहाँ मिस्टेक है।
कोई नहीं, मैं भेज दूंगा आपको, 1-2 दिन में भेज दूंगा। ठीक है,
ओके सर,
तीनों
ओके
सभी
सर,
तीनों लेक्चर
ओके
भेज दूंगा।
ओके सर।
लविश अनम्यूट। हेलो लविश, अनम्यूट करो।
यस सर।
हाँ जी,
यस सर।
आपने हैंड रेज किया था।
नहीं सर, वो गलती से हो गया। नहीं, मैंने पहले का ही नहीं किया सर, सॉरी।
ओके ओके। दलीप, अनम्यूट योरसेल्फ। आपकी आवाज नहीं क्लियर आ रही दिलीप मुझे।
हेलो सर।
हाँ जी हाँ जी,
तो
हेलो
बोले
बोलो
कि सर मेरा हेलो हेलो सर।
बोलो बोलो दिलीप।
सर बोले कि मेरा जो फर्स्ट पोल था उसको नहीं हुआ था, बिकॉज मेरे यहाँ नेटवर्क प्रॉब्लम था और मेरा प्रोसेसिंग इसी कर रहा था आधे
मैंने
घंटे
मैंने
से।
मैंने दोबारा उसको रीलॉन्च किया था।
सर तो मेरे आधे घंटे से जैसे 1 घंटे लेक्चर हुआ ना, फर्स्ट टाइम से 1 घंटे चालू होता उस समय उसके बाद से मैं आधे घंटे पूरा ऐसे प्रोसेस।
अमीन, अनम्यूट योरसेल्फ।
ਡੇਟਾ ਨੋਟਸ ਵੀ ਜਿਹੜੇ ਤੁਸੀਂ ਪਾ ਦਿਓ
हाँ जी
ਆਪਣੇ
हाँ
ਜਿਹੜੇ
जी,
ਤੁਹਾਡੇ ਲਿਖਤੀ ਨੋਟਸ ਵੀ। ਹਾਂਜੀ ਸਰ,
पा दूंगा।
ਹਾਂਜੀ ਠੀਕ, ਓਕੇ, ਥੈਂਕ ਯੂ ਸਰ।
Okay students, leave the meeting.